Hello friends, today we are discussing the microprocessor subject, the lecture series in which the sixth unit is there and it is on part 10 of that sixth unit. 8036 DS signal bus cycles and the thread 7 coprocessor is the last part in which we are discussing the system clock. The system clocks are as shown in a figure. The processor clocks and a processor clock period, clock 2 period and clock 2 period for the F1 and F2 frequencies, whereas the clock 2 period for the F1 and F2 frequency. Internal interface DX6 a 15 minutes nanosecond minimum 33 megahertz. It is a frequency which may be the and at 25 megahertz or a 20 megahertz. So the system clock which runs here, which is multiplied by 2, so to improve the performance. A non-linear read and a write cycle with a no state. The clock cycles in which, as is shown in a figure, as there, a clock is there, clock 2, which is multiplied by 2, and a clock signal is here. A B0 to B3 signal is there, which is using the access of a A2 address lines from A2 to A31 and the memory and or IO or data or control signals are there. The during the cycle one, it one is a valid one. Okay, ideal time is shown as shown in the figure, whereas a cycle two non-pipeline, which is the read cycle, in which is also the valid one. Write cycle which is ideal during the first timing cycle T2, T1, and in the next cycle, that is a non-pipeline write operation. The write operation is carried out, then a cycle 2 non-pipeline read operation is there. The read operation is carried out there. So analog ADS signal which is there in a not applicable signals is there, which is of the so BS16 bus 16 signal, which having the 32-bit bus size, a 32-bit bus size ready, ready, ready pin is there, which having a line during the cycle T1, the ready pin is activated, and during the cycle T2, the ready pin is again this. So the lock pin, which is at the valid 1, valid 2, valid 3. So D0 to D31, that is the data lines are there. So which are giving here as shown in the figure. T1, the first clock of the non-pipeline bus cycles. So there the T1 which is shown, which is a first clock of the non-pipeline bus cycle. The T2 which is the suspended clock of the bus cycle when a NA signal has not sampled asserted in a current bus cycle. TI is an ideal state. TH is the whole acknowledged states. And the fastest bus cycle consists of the two states are the T1 and a T2. As in a figure, the T1 is a the T1 is the first clock of the non-pipeline bus cycle, and the T2 is the subsequent clock of the bus cycle when a NA has not been sampled asserted in a current bus cycle. TI is an ideal state. TH is an whole acknowledged state. The the first state bus cycle consists of the two states is a T1 and a T2. The asserting B16 is a not in a no wait state as shown in a figure. The clock signal which is upon T1, T1, T2 signal clock signal is there. B0 to B1 and B2 to B3. Okay, and A2 to A31 address lines are used here. The read and a write operation carries out the ADS signal. Okay, uh, so not NA signal is there in which during the T2 the don't care situation is occurred during TS16 is signal is there a ready and a log signal which is a valid one during the T1, T2, T1, T2 cycle 1A non-pipeline write and read operations. A lock D0 to D15 which is a D16 to D31 that is a data bus signals which are shown asserted D16 in a wait state as shown in again a figure. NA must be ignored negated here to allow a recognition of a asserted bus 16 in a final T2 signal, whereas NA16 must be the stable during this time defined by the T17 and the T18 of a bus 16 setup and a hold acknowledgement as shown in a figure. A transfer requires 2 cycles on a 16-bit data bus cycles. This is how the timing information carries out. The T1 is the first clock of the non-pipeline bus cycle. T2 is the subsequent cycle of a bus cycle when a NA has not been sampled asserted in a current bus cycle. T T2 is a subsequent clock of the bus cycle when a SA has been sampled as a asserted in a current bus cycle, but there is not yet an internal bus request pending. T2P is a subsequent clock of a bus cycle when a NA has been sampled, asserted in a current bus cycle, and there is an internal bus request pending. T1P, the first clock of the pipeline bus cycle. Ti is an ideal state. Th is a hold acknowledged state. Asserting NA for the pipeline address gives access to 3 more bus states T21, T2P, and T1P. Using the pipeline address, the fastest bus cycle consists of the T1P and a T2P. Whenever the T1 is hold negated, that is a no, TH is a hold negated, that is the no request is sent, and when a T1 TI is ready for, that is an hold asserted. Okay, when a T2 is ready asserted and a hold, the signal is transferred to the TI, arrest asserted, hold negated, not requested. 80387 NDP, that is a numeric data processor, that is we can say a 387 coprocessor. A coprocessor, a control bits for the coprocessor supports. A coprocessor is nothing but the NDP for the 386. The coprocessor is a 80387. The 80387 register stack, it consists of the 387 register tag, data types, load and store instruction, trigonometric and transcendental instruction, interfacing signal, read for 80387. These are the control bus register bits of the coprocessor supports. 80387 register 80387 NDP consists of the 80387 register stack, the 80387 data types, load and store instruction, trigonometric and transcendental instruction, interfacing signals. The feature for the 387, it is in high performance 80-bit internal architecture. 80387 is an 80-bit internal architecture with an high performance. It implements the IEEE standards. It is implemented on a IEEE standard, that is a 754 at a 19854 binary floating point arithmetic. This is expanded Intel 8036 data types to include a 32-bit, 60-bit, 64-bit, 80-bit floating point, or a 32-bit, 64-bit integers and 80-bit BCD operands. Extends internal 386DX CPU instruction set to include trigonometric, logarithmic, exponential, and arithmetic instructions for all data types. It extends the Intel 386DX CPU instruction set to include the trigonometric, logarithmic, exponential, and arithmetic instructions for all data types. It supports transcendental operations for a sine, cosine, tangent, arctangent, and logarithmics. It builds in exception handling, so it has a capability, built-in capability for an exception handling. It operates independently in all modes, that is of a 387. Uh, so it can operate independently in all modes of the 0386, which may be the real mode, protected mode, virtual mode. The 8 it has a 18-bit numeric registers. That's 387 NDP consists of the 18-bit numeric registers. It has available a 68-pin PGA packages. It is available in a NDP at 0387 NDP is available numeric data processor, which is available in a 68-pin PGA package. One version supports a 16 megahertz and a 30 or a 33 megahertz. The register used for the 8087 are as shown in the figure: S0, S0, S1, FLDY, FLDZ, FL, FADD. Stack diagram is shown here. Okay, registers. A data register which has consist of the 80-bit register. A tag word. A tag word marks the content of the each numeric data register. 2 bits for each data register. The status words. The 16-bit status word reflects the overall state of the MCP math coprocessor. The tag word marks the contents of the each numeric data register, 2 bits for each data register. The status word, the 16-bit status word reflects the overall state of the MCP math coprocessor. Instructions and a data pointer. 2 pointer registers allow identification of the failing numeric instructions, which supply the addressing of a failing numeric instruction and the address of its numeric memory operand. The control word, the several processing options are selected while loading a control word from the memory into the control register. The instructions and a data pointer. 2 pointers registers allows identifiers of the following numeric instructions, which supply the address of the following numeric instructions and the address of the numeric memory operands. MCP status word, which is shown in a figure. Error summary status bit is ES is an immerse error summary bit is there. A stack flag SF is a stack flag exception flag, that is a precision. PE precision exception flag. UE that is a underflow flag. OE flag is an overflow flag. Zero E flag, ZE flag means a zero divided flag. Denormalize flag, that is a denormalize the operand, that is a D flag, and IE is an invalid operations. Yes is set if any unmasked exception bit is set, cleared which is otherwise. See the table 2.2 for interruption of the handling conditions. Top values are the 000 register, 111 register. For definition of the exception refers to the selection entitled exception handling. The B bit, which is the MCP busy bit, okay. A top bits of the flag stack pointers, and a C3, which is the condition code. Thank you friends for watching the video.